The following is a presentation of the automated driveway and sidewalk spreader developed by Team Snap Crackle Salt. Each team member will provide a brief presentation of the section they worked on. We'll start with Sean Clark presenting the mechanical design.
Hello, my name is Sean Clark, and I'm going to be talking about the mechanical design for the automatic salt spreader. The salt delivery system has a 5-step system. First is the reservoir. When we pull the blue latch back at the top, it reveals a reservoir, which will keep the salt isolated from all electronics. From here, the salt will fall to the bottom due to gravity, but we will need to work against that to get the salt where we need it next. We accomplish this, but with an auger. The auger will take a controlled amount of salt up to the top of the system. From here, the salt will fall into a funnel. In the funnel, the salt will go to a specific compartment in the wheel. When the wheel rotates, it'll fling the salt and it'll exert a force on the salt and therefore spread it. And at the very end, there will be a flap that'll control the direction that the salt is spread. The automatic salt spreader has a modular design, meaning it has both a static and dynamic function. For the static function, a bracket was designed to hang the salt spreader on the wall. The salt spreader hangs on the bracket similar to how you hang your clothes up on a rack, except there's a stopper there to keep the salt spreader parallel to the bracket. There's also a key to prevent the salt spreader from sliding up along the rail. The salt spreader is also designed to fit on top of the SN5200 robot chassis. This chassis is designed by a company that's not willing to release their CAD files. However, based on dimensions they gave us, we're assured that this would easily fit on top of the robot chassis.
Hello, my name is Benjamin Rojeski, and I was the designer of the electrical system for the ASAT. My goals for this system were to designate the pins on the Arduino to allow proper communication for the circuit. I needed to provide power for all the motors and servos necessary for the project. I needed the necessary IC to drive the motors. In order to power these motors in its drone mode, I needed a properly sized battery to power it for long enough, and I needed to provide a way for the first and second Arduino to communicate. The first Arduino is attached to a computer, which gives weather data to the second Arduino, which is on the robot. Here you can see the transmitter circuit. This will be attached to a computer, and here we can see the 12-volt barrel jack for the stationary mode and the battery for the drone mode. The battery would be around 5,000 milliamps, and as long as it could have about 50 C, would be good enough to provide current for enough of the robot. Here you can see my implementation. I'll divide this into subsections shortly, but right here, this is the main brain, this is the Arduino, it controls all the other subsections. Here we have a reset switch just in case something goes wrong, and here we have the receiver that takes all the data from the transmitter. Here is the steering motor subassembly. I decided to use an H-bridge for it, as I thought that would be the best way to implement it. Here we have a safe amount of power from our voltage regulator. It goes into it, gets controlled by the Arduino, as we can see on the left, and on the right we have two motors. Sadly, the Arduino Uno does not have enough PWM pins for speed control of both the motors, but no speed control still works fine for this project. Here we can see the quantized salt amount and area distribution subassembly. These are all the components that decide how far, where, and when the salt gets spread. Here we have the auger motor. I decided the stepper motor would be the best tool for this job, as you could count how many steps the auger turned, which would allow you to count how much salt is getting dispensed. Here we have a servo, which would control the door angle for the spreader, which would allow you to choose where the salt is spread. Due to limitations of the Arduino, we have to power this with its own separate voltage regulator. And finally, we have the spreader motor. Again, due to the Arduino's power issues, I had to design a transistor circuit to allow the Arduino to turn the motor on without directly powering it. And that is the electrical subsystem of the ASAT device. Thank you.
Hi, I'm Richard, and I would like to demonstrate the ASDS control app. So this is the ASDS control app. Right now on the main form, what you're looking at is some of the relevant weather information that is being sent to us through OpenWeatherMap.org's API. Um, we're also using Google Static Map API and the Google Geocoding API for satellite images of your driveway or parking lot or whatever needs to be salted. So, just real quick demonstration of some of the different options that we have available. Right now, I can change the street address, so I'm going to just use Oakland University so we can take and see the relevant local weather and satellite image data there. So, 318309 for the zip code. Now, I've already have it set to imperial units, so let's switch to metric units. We'll go ahead and hit apply. That's going to reload the main form. Okay, so now we've got the city of Rochester. We've got all the relevant temperature, pressure, humidity information. So now let's take a look and see what the satellite image is going to be for the address that we just put in. Okay. And so 318 Meadowbrook Road, as some of you may know, is the Oakland Student Center. And this will, using Alex's program, trace this back lot here and have the drone get the relevant length and width from Alex's program. And to demonstrate that length and width data is being sent, I've set up my own Arduino with a LCD screen, and we are going to see serial communication from the weather app to an Arduino. So I'll just hit the length and width data I've got stored in my app config file. So I hit start salting here, and there we go, length and width data.
My name's Alex Sam, and for my part of the project, I developed a program that allows the user to select the salting area and output the length and width. So what we have here is a WPF form. It actually uses XAML as the designer and C# as the CS. So with that, we're actually able to better control the objects that we pull into the program. One of those objects being this canvas here, which is partially transparent, that we're using as our selection area. Using the handhelds, we can manipulate this rectangle, and right now I'm rotating it and resizing it while it's rotated, which is actually something that's very difficult to do in a Windows format. So in this demo, I'd actually like to go over how we handle resizing the selection area after it's been put on the screen. So these rectangles here that you see are actually objects that we've generated through system.windows.shapes directory over here. And by changing the position, we actually calculate where the side length should end up in relation to these rectangles, which doesn't sound all that difficult, but when we have it on an angle like this, we actually have to use transform groups and trigonometry to find out how the rectangle should respond to being transformed at an angle. Most important part of this program is actually grabbing the length and width after we're done manipulating this selection area. And we can do so by pressing this finalize button, and it'll tell us that we've got 202 pixels in width and 211 in height. And for the purposes of our demonstration here, I have it doing that, but we've also got code written in Richard's program that will handle taking the pixels and sending that to the Arduino.
Hello everyone, my name is Drew Waite and I was responsible for the Arduino code part of our project. So obviously the Arduino was responsible for all the movement of our robot. This included tank treads, the auger stepper, the salt spreader, and the adjustment servo. Using serial communication over radio transmission, the Arduino is able to make sure the desired area is properly salted. This information includes length, width, and mobile or stationary salting modes, and it's given from the desktop app. The current Arduino code, though, asks for manual input of driveway length and width and salting mode, just so that it's easier to demonstrate. Luckily, this is very easy to implement from the web app, though. So this slide kind of goes over some of the basic functions that I wrote for my code. We started with a setup function, and then I had a drive function, which includes a string motor and integer rate input because each motor is driven individually. Then I made a break function that also takes a string motor input, as well as a left turn, right turn, and loop functions. So next I wanted to talk about the basic movement plan for our robot. The first thing you need to know is that the salt spreads in about a 1 foot radius from our chassis. Also, a servo at 90 degrees will cause a salt to spread in a quarter circle instead of a half circle. This is to avoid salting the grass as much as possible. The basic idea is that we would spread down the right side of the driveway with the servo at 90 degrees, then turn our chassis, drive 2 feet, turn again, open the servo back up for full spreading, and then drive back down the driveway. We would then have a snake pattern until the entire driveway is salted. So this slide gives a very simple animation of what the salting pattern would look like. As you can see, the servo starts at 90 degrees, having a quarter circle of spreading until it gets to the bottom of the driveway, where it turns, drives 2 feet, turns, opens the servo back up, and then drives down the rest of the driveway. We then have the snaking pattern you can see right now until the entire driveway has been salted. Lastly, I just wanted to show you a quick demonstration of the manual serial input of the Arduino code. Hello everyone, this is Drew, and I just want to give you a quick demonstration of the Arduino code that I wrote for this project. As I said in my presentation, the Arduino code right now is set up to take manual inputs just for ease of demonstration. So I'll go ahead and show you that right now. As you can see, the first question says please insert the width of your driveway in feet, which I'll go ahead and put 10. Then it says, and then it asks for the length of your driveway, so I'll go ahead and put 15. And then it says mobile or stationary salting. This would be much better once we get our Arduino radio communication working, where one Arduino could just send a 1 or a 0 to the other one. However, for now, we'll just go ahead and put 1 for mobile salting. And as you can see, the code recognizes this and says ready to start mobile salting. Please make sure the driveway is clear of all obstacles before beginning. If I were to put in a 0 there, it would know that it's stationary, and it would say ready to start stationary salting. It would then go ahead and just salt the sidewalk right from your porch. So thank you all for watching my demonstration, and I hope you have a good day.
This project would not be possible without the hard work of each team member. Thank you for the opportunity we had to put our knowledge and skills to the test.